Okay, so in this video, I'm pretty much just going to draw a diagram and then say a couple things about that diagram. But this diagram is kind of illustrating what we've learned up to this point in ECE 45. Okay, it's everything we've been building toward. And I like to call this diagram the Lti System Box Diagram. Okay, and here's what the story is. So we have an input x of t, and it goes into an Lti system. It goes into an Lti system. And typically you've been putting the frequency response inside of an Lti system. But as we've seen now, the frequency response is just the Fourier transform of the impulse response. And so sometimes we also write the impulse response in an Lti system because either one, as we're going to show in this diagram and as we've seen before, allows you to get the output to an Lti system given the input and either the impulse response or the frequency response because they're just Fourier transform pairs with each other. Okay, so sometimes when we want to kind of highlight the time domain situation of an Lti system, we'll put the impulse response, h of t, because it's in the time domain, and other times, as you'll see in this diagram, when we want to highlight the frequency domain aspect of an Lti system, we'll put the frequency response. But okay, so x of t, an input goes into an Lti system with impulse response h of t, and we know what the output is. Okay, we've now seen this. The output is the input convolved with the impulse response, okay? And we'll get to much more about convolution as we go through the class. But this is the story kind of just staying in the time domain, okay? What else could we do? Well, there's kind of an alternate path we could take, and that is going into the frequency domain. So we know that the impulse response and the frequency response are Fourier transform pairs. That's what that double arrow means. And so what would be an alternate path in order to get from x of t to y of t? Well, instead of staying in the time domain and going across this top path, we can actually take a detour. Okay, we can take a detour that seems longer, but sometimes it's actually simpler. And what we can do is we can first take the Fourier transform. That's a symbol I sometimes use. It's kind of like a calligraphic F type thing to mean the Fourier transform. Okay, those are the same thing. Just so I don't have to keep writing ft and ft inverse and stuff, I can just use a symbol. So we go into the frequency domain and we get x of omega, and then we put that into our Lti system. And what do we get out? Well, we get out the Fourier transform of our output, y of omega, and as we've seen, that's just the input Fourier transform times the frequency response. And then if we want the output in time, of course, we can always take the inverse Fourier transform. Okay, so this is sort of the Lti system box, as I call it, because it sort of looks like a box, and there are sort of these two main paths. You can either, if you're given the input x of t and the impulse response h of t, you can stick in the time domain and go through the top path, or alternatively, you can take this detour, which looks longer, but actually sometimes can be an easier computation to perform, going the long way. Okay, and in either case, you eventually get the output y of t, which is often what you want. Okay, so let me just write that down. So given an input x of t to an Lti system with impulse response h of t, okay, there are kind of these two options we can take. So option one, all we have to do is convolve x of t and h of t to get y of t. And you might be thinking, well, great, why don't we just do that every time? Turns out this convolution operation, as we'll see later in the class, can sometimes get a little messy, get a little tricky. And often it's easier to go into the frequency domain because then you just have to deal with Fourier transforms, which could be easy or hard, but let's just say for the time being, they're easy ones. Okay, and then all you have to do in the frequency domain is multiply. And multiplication is usually pretty easy. Okay, so often this convolution operation, although it's the direct path, can be more difficult than this other option, option two. And what do we have to do here? Well, first, we're going to take the Fourier transform of x of t to get x of omega. Okay, that's this first step. Okay, and then next, we'll take the Fourier transform of h of t, the impulse response, to get h of omega, the frequency response. That's kind of this step. And now we want this output, which is just the product of them. So we're going to multiply x of omega and h of omega to get y of omega, Fourier transform of our output. And then finally, we can take the inverse Fourier transform of y of omega to get y of t. Okay. So those are kind of the two typical paths. If you're given the input and you're given the impulse response, how you can get the output y of t. You can either take the direct path straight through or this detour. And sometimes each one could be easier than the other one. Okay. So this is kind of what we've been building up to in the class so far. And you can see everything in this diagram we've had to explain, right? We had to explain what's an LTI system. We had to explain what's a signal. We had to explain what's an impulse response, what's a frequency response, what's a Fourier transform, right? What's an inverse Fourier transform, what's convolution. So this would be a good place to stop and make sure that everything I just named, you're comfortable with, you're familiar with. And if not, you can always go back and watch the previous videos. But yeah, this is kind of what ECE 45 has been building up to so far. And we're going to be using all of the things in this diagram a lot going forward. Okay, so that's it for this video. I will see you in the next one.